Hi everyone, welcome to this lecture. In this lecture, we'll learn how to run a machine learning supervised classification with a Landsat 9 satellite data. And this is a synopsis or an overview of the JavaScript code that we'll be using to run the supervised machine learning classification using a random forest algorithm. And you'll have access to this bit of code. I'll put the link to this code. Let's get started. So Landsat 9. So Landsat 9 data, the satellite Landsat 9 was launched September 27, 2021. And so the Landsat 9 satellite has two instruments on board. The first one is the operational land imager, which is called OLI2, and this instrument has 9 bands, including the visible, near infrared, and shortwave, infrared wavelengths, and the thermal infrared sensor 2 or tiers 2 has 2 bands. The first one is a 10 meter band 10 and band 11, and their spatial resolution is 100 meter. And when you look at the tiers, the OLI bands, all of them are 30 meter spatial resolution except the band 8, which is a panchromatic 15 meter. Okay, so these are the bands of the Landsat 9 data. So the satellite stores data as it scans the Earth's surface, stores information on all of these bands, in the OLI as well as the tiers in the thermal infrared instrument. So we'll be using Google Earth Engine cloud computing platform. Those of you who are new to Earth Engine, you can go to this website and click sign up to apply for an account. And Google provides this service for educational training purpose or non-profit application or research purpose, and usually they approve the account within 24 to 48 hours. So that's how you submit the application to get granted to the Earth Engine cloud computing platform. And so the next thing is if you click datasets here in the Earth Engine data archive, you have a library of data which includes various satellites including Sentinel, MODIS, Landsat, and many other geospatial databases. So because we're using Landsat 9 in this case, let's just go to Landsat here. So you have different Landsat sensors, Landsat 9, 8, and 7, and the other legacy Landsat sensors. So let's click Landsat 9, and within the Landsat 9 you have 3 different options. The first one is surface reflectance, and you have the top of atmosphere, the second one, and the third one is the raw image or the raw data. And for our purpose, we'll be using the surface reflectance dataset with tier 2. And so as you can see here, you can check in this image collection ID, and you can later import that programmatically using a JavaScript API. Okay, so the other most important thing is if you go to platform as code editor, you'll have access to the code editor playground where you can write your JavaScript program and execute code here. And then you also have a map canvas to visualize your results of the analysis or exploration in real time. In addition, you also have this console where you can monitor or debug your code, and then print some of the error message and things like that. Okay, so let's just get started. And so this is a script that I've already written, a machine learning classification algorithm that uses a Landsat multispectral band and uses a training data set and runs a supervised classification using random forest algorithm, and also in addition generates some sort of stats, accuracy assessment stats. Okay, let's get started. So I'll just I put the code in different chunks, so I'll uncomment this version. And so the first one is to import the Landsat image collection, as you can see here, LC09, which is the Landsat data. And since the data is a large data in terms of space as well as time, temporal resolution, we need to filter it both spatially and temporally. That's what we're doing here. We're doing here a filter depth and also filter bound. I'll generate a region of interest myself in a second here. And the other important thing is when you deal with Earth observation data, optical remote sensing data, you need to do some cloud masking to remove some of the cloud contaminated scenes. That's what we're doing here. And before we execute this code, let's just create our region of interest actually. And so the first thing we need to do is, so this is a global view. We haven't created a region of interest, that's why we're having some error here. So the first thing I'll do is just let's search Swaziland. In the search, Swaziland, and it will take us to that study area. This is in small country in the southern part of Africa. And so let's just create a study region or like a box to run our classification or machine learning analysis. Okay, so this is an Earth Engine geometry creation tool. I'll just click this box to create a rectangle, region of interest, our study area, and this is my study region, and then I'll name it ROI, which is region of interest. Okay, and now we have created, when I create this, it will automatically generate this ROI. It will show me, or it will input it in the code editor automatically so that I can access it. So I'm importing this here, ROI, so my Landsat image will be subsetted to this study area. Okay, and so I have the study region. The next thing is, I need to apply some sort of rescaling factor to read the data in an appropriate data range. So this function, what this function does is literally multiply both the optical bands and the thermal bands to some scaling factor. Okay, and I'll apply this function to the entire image collection, which is my data set here, and generate a median statistics, because this is a time series data, so we want to generate one single image using a median stat. And finally, I'll just create some sort of visualization parameter here, and I'll provide the different bands that I'll need to visualize, which is the true color composite here in this case in Landsat 9, band 4, band 3, and band 2, and then apply that visualization. And so I'll just run this script, and what I have now is, actually let me just uncheck this so that I can look at the Landsat data. Okay, so this is my Landsat data. Which is not perfect. There's some cloud contamination, but a very, very insignificant part of the study region. Most of the area is pretty clean, right? because we have tried to remove most of the cloud contaminated data sets. We have provided a parameter here, 10 meter. That means we are using only Landsat 9 image with cloud contamination less than 10%. Okay, so this looks good. This is a pretty good clean scene. Okay, so the next step is now we have our Landsat 9 image, and so the next step is to actually generate a training data. To do that, I'll uncheck this part of the code. Okay, so what this does is, assuming that we have already a training data using barren, forest, water, urban, and crop, it will just merge them into a single file, and then later this training will be just applying using this sample regions approach. It will overlay that to the Landsat image. Okay, that means it will extract all the bands, all these bands into the training data sets. Okay, so what we'll have is a response variable as the training data, and also independent variables in terms of the prediction, all the Landsat bands. Okay, that's what we're doing here. And the next step is, let's create the training data here by clicking this point data here, and I'll create the first training for water and change it to feature collection and add properties here, class 0. Okay, and I'll make it blue. Let's actually capture some data point for water. Actually, I can get rid of that here. Or we have some water data point here. Let's just add the Landsat data. So we can click the water data and just generate as much data points as possible to represent water body, right? So as I keep adding these water data points, it will just automatically add them here and also here. Okay, so we're just technically generating or creating a training data points for water class for our machine learning classification. And so I think that should be fine for the water class. Okay, and the next is I'll create another class, which is the urban class, and I'll name it class and then 1. And that should be it. And then it's active. To just digitize, you need to make it active. So let's just look for some urban area, and let's just click that pan and look at some urban area. Probably this is the more urban area, right? Let's just see. Okay, so this is a good representation of some urban pixels. So I'll go ahead and then generate this. I'll click here and then generate the the urban pixels. These are more urban area in the main city. Over here you have some urban pixel. I can also drop the satellite background here. Okay, and I can overlay the Landsat data as well. A little pixelated, right? And I can use the Google background as well. So we have pretty good enough number of urban class, I think. And the next one is a forest class to represent some vegetation cover, and I'll call that class number 2, and then mostly green. And let me find a vegetated area, right? So this is our Landsat image. You can clearly see that in the Landsat data. Okay, this is mostly forested area. You can clearly see that in the Landsat image as well. Let's just go ahead and create forest, training data. All right, so I'm creating some forest training sample, so that I'll be able to run the classification later using a random forest algorithm. And next one is to create a crops training data point, and I'll name it crop. And again, I'll just provide the class name, and the class code will be 3, and then I'll just click that. And let's find some crop area. Let's find some agriculture. I think we can use the satellite data, I think, to make sure that we are using the right agriculture area. We have actually a pretty good representation in the northern part of our study region. Let's just look at the Landsat image here. Yes, this is good representation of farmland. So we can use all of this. This is agriculture, right? So let's just use this crop area to generate this training data, okay? And I'll drag a little bit down, and again click. It has to be in bold or just highlighted to be able to generate the to capture the training, okay? And so if you zoom in here, some part of this area it's pretty confusing with barren versus crops. So I have to be careful just when I capture those training data sets, right? And let me find another location where we have some agriculture. Okay, and I can see some here, pretty clear agriculture area, right? So this is a fairly clear agriculture classification. So let's just capture some of these data points. Okay, the next is to create actually a barn class, which barn, and I'll create a property here. I'll give it number 4, and somehow barn class, I'll just change it to gray color, and let's just create some training sample. So this is our region of interest or study area. I can see some barn area here. And I would say something like this is a barn. So we have about pretty good number of samples. So now the next step is to actually so we have So we have created all of our training data here, and we merged them into, so we have different class, right? Water, urban, forest, crop, and barn. So we'll merge all of these feature databases here, and this is the script that does part of the function that does merge all of this, right? So our training is here, and then it will merge barren with forest and then water. So all of that training is merged into a single database, which is training. If you want to export this for future analysis, you can do so to Asset Manager, but for now we don't want to do that. In this example, we'll be just using as it is, okay? And then the next thing is we have now our training data, which is XY location, and also ground truths or training data for 5 different land cover class. And now the next step is to actually extract the Landsat band values, and merge that into our training database. That's what this chunk of code is doing. So it will, using a samples region approach, it will use the training data that we have created and merge it with the input, which is the Landsat image, and our properties. In this case, the classification is the class or label here, right? And different bands are these are the different Landsat 9 bands, okay? And so this will just create a training data with land cover class plus all of the bands, the Landsat 9 bands that we'll be using in the classification, okay? And the next part is, before we run the classification, we need to split the data into 80-20%. So we'll use we'll generate a random column to the database, the training database, and we'll split 80% of the data we'll use for training the model. We'll call it train set, and the test set is 20% of the data for later accuracy assessment, okay? And now the main part is to actually execute the supervised classification. And in this part of the code, we just use the Earth Engine EE classifier smile random forest that will implement the random forest algorithm built in Earth Engine classification, and also import the train set. You see the train set here, and two important things. The first one is the response variable, the dependent variable, and the other one is the input property. In this case, the bonds, the Landsat bonds are the predictor variables, okay? And once we have implemented the model, we'll just apply that model to the class, to the image, to generate a land cover predicted land cover map. This will achieve that. So we're importing the Landsat image and applying classify, and then we're calling the model we already implemented, right? So this is our classification model, a classifier. And lastly, we need to visualize the data. So we have generated a classification, and then we need to visualize it, okay? So we have already created our training based on this. So we provided water 0 value, urban 1, forest 2, crop 3, and barn 4. So we'll provide the classification color map or color palettes accordingly. And instead of just running it for the entire scene, we'll just clip it by a region of interest, okay? And then we call it classification. Let's execute that. And we should be able to visualize land cover map. Here you go. So that's our land cover classification using a random forest algorithm and using Landsat 9 multispectral bands, okay? So, visually inspecting, this classification, it looks pretty good, right? And, if you look at here, for example, if you look at the water area, which is the easiest, right? We are able to, detect that water. And if you look at some of the, the green forest areas, we are also able to capture that, okay? And then also the, some of the agriculture area, if you look at that, you can see we are, we have fairly predicted some of this yellow area, which is the agriculture. We're not 100% perfect, but we have captured most of the pattern, right? And so we feel good about this visualizing, visually inspecting that land cover classification. But let's just do one more step, which is more a quantitative analysis or a quantitative accuracy assessment. That's step 4. And let's just execute that code actually. So this will just generate a confusion matrix, overall accuracy, and if need be, you can also generate producers and users accuracy. So let's execute that, and we should be able to see that result here. So our classification has an overall accuracy of 72%, which is okay. And we also have some producers and users accuracy. You can visualize that or just export it as a CSV table if you want to. And the final step is just to actually export the land use land cover map, which is handy, right? You might want to use this in other geospatial software such as ArcGIS, QGIS, and whatever geospatial software that you want to add this and visualize or do some additional analysis, right? So let's so this export function does that, and then we have an image, which is the classified image, and a description. You can change that if you want to. And this is the spatial resolution of the data, and region of interest and max pixel is usually to avoid maxing out your usage of the Earth engine. Sometimes you limit your cap, so this will help you to avoid that. And then I'll go ahead and execute that. So under the tasks menu, you'll automatically have this export feature here. You just click run, and you will automatically export that to your Google Drive. So you have now an image, a geotiff image with land use land cover map that is generated using random forest supervised classification on the Earth Engine platform using Landsat 9 data.